Hello students, welcome to Eduauraa. I am your physics mentor Umesh Nirgun, and today I would like to discuss the previous year question of the surface tension. A capillary tube A is deep in water, another identical tube B is deep into the soap water solution. Which of the following shows the relative nature of the liquid columns in the two tubes? So let me discuss the diagram one by one. In my first case, I can say option A. I have the two containers. First container and the second container, which is called as what? A and B. Okay. The capillary, it is immersed in the A and the liquid rises up to certain height. And the surface, it is concave surface. Then I have the container B. In the B, again, it is a soap solution. The liquid level rises up to certain height. The surface, it is a concave. But the height, it is less than what? A. So moving on to the option B. What is option B? Again, we have the two container, A and B. Okay. A, we have a water, and B, we have a soap solution. So in the A, the water level gets what? Increase up to certain height. Okay. And in the B, the water level also gets increased up to certain height, but the height in the B, it is greater than the height in the A. Okay, both the surfaces are concave, but height in the B, it is greater than height in the A. Now my next option, C. In C, again I am having the two container, A and B. Okay. In the A, we have the water. Okay. But the water, it is at the same height. And in the B, we have the soap solution. It is increases up to certain height. So this is my option C. And let us check what is option D. In D, again we have the two container and A and B. Okay. In the A, we have the capillary. In the B, we have the capillary, and the height in the A, it is same as that of the height in the B. Clear? So these are the different options. So I have to check the correct option and I have to explain why it is the correct one. Now the height of the liquid column in the capillary, it is given by H is equal to 2t cos theta upon r rho g. Now the radius, it is what? Same. Rho, it does not remain same, and the very important one, the surface tension and the height, they are what? Directly proportional. H is equal to 2t cos theta upon r rho g. Means as the surface tension gets what? Increases, the height in the capillary, it gets what? Increase. And what about the cos theta? Cos theta, it is less than 1, or we can say for the water or the soap solution, theta, it is less than 90 degree. And as the theta, it is less than 90 degree, then the surface, it must be a concave surface. Now surface tension of soap solution, it is less than the surface tension of water, because we have studied that when the partially soluble impurities are added. What is the concept? Partially soluble impurities are added, the surface tension decreases. And as the surface tension it gets what? Decreased, the height should be decreased. Okay. So I can say the height of the water column, it must be greater than the height of the soap solution. Why? H is equal to 2t cos theta upon r rho g. Now observe all the options. In the first case, I can say in the option A, the height of the water, it is greater than the height of the soap solution. So this option, it is the correct option. Yeah, because in the second, the height, it is greater in the B, or we can say in the soap solution, but the surface tension of the soap solution, it is what? Less. So the correct option is option A. So student, here we have the next question. Work done in increasing the size of soap bubble from a radius of 3 cm to 5 cm is nearly, in the bracket, surface tension of soap solution is 0.03 Newton per meter. And the options are option A 4 pi millijoule, option B 0.2 pi millijoule, option C 2 pi millijoule, and option D 0.4 pi millijoule. What is given? Initially, the radius of the soap bubble R1. So this R1 is equal to 3 cm. Now we have increased the size of the soap bubble. So the new radius R2 is equal to 5 cm. Surface tension of the soap solution, it is given. It is 0.03 Newton per meter. And what we have to find out? We have to find out the work done during this process. Okay. What is the formula of work done? Work done is equal to surface tension into increase in area. So work is equal to surface tension into increase in area. So that is equal to T into 4 pi R2 square minus R1 square. But as we have the bubble, it has the two surface area, the inner one and the outer one. And that's why it must be multiplied by 2. So into 2. So it is 8 pi T R2 square minus R1 square. So this is the work done. And we have to keep pi as it is, because in the options, the answer, it is given in terms of pi. So it is 8 pi into 0.03. R2 square, so it is 5 square, so it is 25. 25 minus 3 square, so it is 9. But it is in the centimeter. So centimeter, it is nothing but what? 10 power minus 2. Square of that, so it is 10 power minus 4. So 8 3s are 24. So 0.24 pi into 25 into 9. So it is 16 into 10 power minus 4. Now I can do the calculation. I can adjust the power of 10. So it is 0.24 into 1.6 into pi into 10 power minus 3. 0.24 into 1.6. 16 fours are 64. 6 carry. 16 twos are 32 plus 6, 38. Okay. So it is 0.384 pi into 10 power minus 3 joule. But 10 power minus 3 joule, it is what? Millijoule. So it is 0.384 pi millijoule. So that is approximately equal to 0.4 pi millijoule. So the correct option is option D. So this question, it is very, very important. It's a 2011 question. So student, here we have the next question. A thin liquid film is formed between a U-shaped wire and a light slider supports of weight 1.5 into 10 power minus 2 Newton. See the figure. The length of the slider is 30 centimeter and its weight is negligible. The surface tension of liquid film is, and the options are option A 0.0125 Newton per meter, option B 0.1 Newton per meter, option C 0.05 Newton per meter, and option D 0.025 Newton per meter. So let me draw the diagram. Here we have the U-shaped tube, okay, and here the thin wire is there. The length of this wire or slider, it is given. It is 30 centimeter. So it is 0.3 meter. And the weight which is suspended over here. So this weight, it is nothing but what? Force. So force is equal to 1.5 into 10 power minus 2 Newton. What we have to find out? We have to find out the surface tension. So T. What is the formula? Surface tension, it is defined as what? Force acting per unit length. So T is equal to F by L. But as it has the two surface area, I can write down it as F by 2L. Clear? So F is equal to 1.5 into 10 power minus 2 divided by 2 into 0.3. So 2 into 0.3, so it is 0.6. So 1.5 divided by 0.6 into 10 power minus 2. So that is equal to 15 by 6 into 10 power minus 2. 3 2s are 16 and 3 5s are 15. So it is 5 by 2. So it is 2.5 into 10 power minus 2. So it is 0.025. And the unit is Newton per meter. So the correct option is option D. It is 0.025 Newton per meter.